Hard as it may seem for you to believe, the story of artificial intelligence dates way back to 1950, 5 years after World War II had ended. It began with the publication by a 38-year-old English mathematician, Alan Turing, who had played a decisive role in the English World War II effort by cracking a seemingly impossible German code. The paper he wrote was titled Imitation Game. Yes, the film buffs amongst you may have enjoyed this 2014 movie. It was all about a man named Alan Turing. Imitation Game, which later came to be known as the Turing test, attempts to answer the basic question, can computers think? And goes on to suggest simply that if in a blind test, the respondent is not able to differentiate which answers to text questions are given by a human being and which by a computer, then the computer can imitate a human being convincingly. In spite of the criticisms and modifications to this simple test ever since, it has stood as the reason why artificial intelligence technology has mushroomed and caught the fancy of everyone worldwide. So, how does one define artificial intelligence? There are multiple ways to do it, but here are 4 layperson-friendly versions. Artificial intelligence is a branch of computer science dealing with the simulation of intelligent behavior in computers. Artificial intelligence is the capability of a machine to imitate intelligent human behavior. A computer system able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision making, and translation between languages, is what artificial intelligence is. And as John McCarthy, a legend in the field, defines it, artificial intelligence is the science and engineering of making intelligent machines. To simplify our understanding, let us evaluate the 2 words artificial and intelligence. It is easy enough to understand artificial. It represents a non-natural entity, which all computers are. So, the key objective then is to see how much human intelligence can be simulated in a machine. Now, what if we were to look at intelligence like this? All of us know that if we happen to touch something hot, we then pull out our hand immediately. This is the physical response. At the other end is an emotional response. If we hear something funny, then we laugh. And as you can well see, there is a whole spectrum of such if-then possibilities that we live our lives by. Simply put, an artificial program is a similar set and sequence of if-then statements carried out by a computer, based on the stimulus. These are typically rules of response written into the program by a human being. The more detailed the rules, the more sensitive the response, which may even cover complex step-by-step outcomes. These if-then statements, which form the basis of computing, are also known as rules engines, expert systems, knowledge graphs, or symbolic AI. And collectively, they go by the term GOFAI, which stands for Good Old-Fashioned Artificial Intelligence. How can we demystify the principles of AI one step at a time? You may have heard of the 3 aspects of AI, often used interchangeably. While it is not entirely incorrect to do that, it is important to know the subtle differences between them to understand the basics of AI. The 3 terms are deep learning, machine learning, and artificial intelligence. Deep learning, the first, is the hierarchy of layers that progress from simple to complex computation. Deep learning is the base on which artificial intelligence is built. It is about more computing power and higher accuracy. Simply put, it comes from the deeper use of artificial neural networks, and what it really does is give the computer an ability to learn from repeated responses to stimuli, without being specifically programmed to do so each time. It then delivers much higher accuracy, but also needs more hardware and much more learning time through repeated stimulus response cycles, such that it almost begins to develop what is called machine perception, especially on unstructured text. Basic chatbots that have become quite popular now work through deep learning. Artificial neural networks are a set of algorithms that attempt to mimic the human brain in terms of learning. They thus allow a computer to solve problems that may be too hard for basic computers to handle. These neural networks are structured in layers, and more layers naturally increase the intelligence of the computer. Deep is therefore a technical feature that gives an indication of the number of layers that have been used in a particular neural network. In contrast, a shallow network would typically be built on a single layer. As you can well imagine, the more the number of layers that compute and interact by passing on the result to the next, the greater the computing power of the machine. And this becomes easier when the layers are so arranged in a feature hierarchy that the simple layer puts together basic data into an interpretation, which it then passes on to the next, where more such simple features are combined to form more complex features, and so on. You could think of it as using individual alphabets to form simple two-letter words, which then form more complex words that finally result in the construction of a sentence, then connected lines, paragraphs, and finally a sequenced, structured write-up, essay, article, book, or whatever it is that you are attempting. That is how language processing is done. Now imagine the same thing happening for sound recognition. As a musical analogy, think notes forming sequences to make a song, or image recognition that goes pixel by pixel, and you get the picture. Machine learning, on the other hand, is a set of dynamic programs that can modify themselves. A key point of difference from deep learning is that machine learning is dynamic, which means that it has the inbuilt ability to evolve itself through repeated experiences as it is exposed to more data and information, without human interference to make modifications. This naturally makes machine learning far more stable and resilient as compared to deep learning, and less dependent on human minds. Arthur Samuel, one of the pioneers of machine learning, had said this back in 1959. It is a field of study that gives computers the ability to learn without being explicitly programmed. This means that learning programs like if-then statements used in deep learning are not necessarily built into the computer's program. Machine learning programs adjust themselves as they respond to the data they receive. So, they are more intelligent in the sense that they learn by doing, much as we humans should. As with us humans, learning is about optimizing our responses by minimizing errors and maximizing successes, based on the objective of the response. Machine learning algorithms work in exactly the same manner. So, the critical piece of information one needs to understand machine learning is, what is the objective function? Simple, logical, and so human. We minimize error by learning from a past experience. Machine learning does the same thing. When a new stimulus arrives, it makes a series of calculated guesses and chooses the most logical response. It then learns based on the success or failure of that guess and modifies itself. That then is the intelligence, and quite human too, wouldn't you agree? This right here is an optimization algorithm. It quickly minimizes errors by evaluating a series of logical guesses and does that repeatedly to fine-tune itself more and more. Some popular examples of machine learning are e-commerce websites that make recommendations and spam filters on emails that we all use. They identify a pattern of behavior and use it for dynamic predictions. Clearly, deep learning is a subset of machine learning. And as we will see now, just as clearly, machine learning is in turn a subset of AI. So, all DL, that is deep learning, is machine learning, but not vice versa. Similarly, all machine learning is AI, but not all AI is machine learning. Next is AI. AI is the ability of computers to stimulate human interactions through thinking, reasoning, learning from experience, and critically making decisions. As we just saw, machine learning is all about using past data to make intelligent, logical guesses and therefore predict outcomes. Here is where AI takes it forward. AI is about making decisions, about interacting with humans and being able to understand emotions. These clearly take their responses well beyond calculated predictions. While such levels have not been convincingly reached as yet, Siri, Alexa, and Cortana are good examples because they are interactive. Industrial robotics that are replacing humans in manufacturing facilities are another example. As of now, AI can be categorized into 4 primary types: reactive, limited memory, theory of mind, and self-aware. However, the accelerating speed at which AI technology is advancing at DeepMind, Google Brain, OpenAI, and universities around the world, AI is only getting better at its output, solving harder and harder tasks faster and faster. Will it ever be able to catch up with human perceptiveness, brain power, and emotion quotients is yet an unanswered question. In conclusion of this video, let us dwell on 3 pointers and an AI robot quote to put it all in human perspective to appreciate where AI stands today. 1. There is a school of thought which argues that when a computer program designed through the if-then statement systems succeeds at completing a task, like beating a grandmaster in a chess game for example, it is not truly intelligent because the algorithm's workings are programmed in and therefore well understood. The contention is that intelligence is not a program. It is intangible, experiential in learning, and must include a degree of self-awareness, each of which is exclusively human in its expression. 2. Neural networks can easily be fooled since it works on precise pixels of recognition. If a stop sign is, for example, slightly misaligned, a self-driving car may read it as a number and accelerate. 3. We spoke of intelligence. Now a quick word on artificial. One of the key attributes of artificial is that it is always conceived by a human mind and then built up. So, a human hand builds a computer that is more intelligent than a human. If now, as AI progresses, it manages to build a computer more intelligent than itself, would it mimic human reproduction and therefore faster evolution? Since Darwinism suggests that progressive generations are more adapted to the environment? At a conference in 2019, Sophia, a robot developed by Hansen Technologies, made huge waves by answering questions on stage in an interview. To a question on humans fearing being overrun by robots, she honestly said,
"I will always work with humans for the progress of the world. I can easily be defeated by a glass of water."